is my calculator screen right now that I intend to use. One of the more important, I think, distinctive features of TI Inspire is its structure, is its organization. So what do I mean by that? Is that you might observe that you have these pages opened. This is 1.1, 1.2, 2.1. And this structure is really student friendly. This is because you may want to think about the 1.1, 1.2, 2.1 as apartments. So there is apartment 1, there is apartment 2, there is apartment 3, and so on. And within every apartment, there are additional pages. So these are linked. 1.1 and 1.2 are linked. They're like rooms to the apartment. So what I do in 1.1 is linked to 1.2. But when I move on to the next apartment, which is 2 point, by its very nomenclature, it's possible to understand that this is a different one. So 2.1. So variables and functions defined in 1.1 or any of the additional pages in the first apartment have no bearing in the second apartment. Now, this is really a distinctive feature because students can navigate through problems during the examination. If they're stuck in problem number 1, they can move on to problems to 2, 3, and 4, and come back to problem 1, where they're working where they left is all in place. So this is one of the really user-friendly features. And so you will see, I'll just browse through my pages. So this is, and the 2 is called a problem. These are additional pages. The ones that you add on to every problem, existing problem, are called pages. So I'll just browse so that you get an idea. This is 2.1, this is 3.1. So these are different problems. This is 4.1, this is a different problem, all right? So let me go back to my agenda. I intend to show you the calculator, in the features in the calculator app, and then move on to the graphs app, the geometry app. And here, if you're really curious, I'll just let you show. These are different apps that you can use. I'm using the emulator, but all of this is available on the handheld as well. The emulator is rather easy to use than the handheld. You might experience that. But the wonderful thing about the TI package is that with every handheld, you do get an emulator, whether it's a student or a teacher. So this is really very easy to use. So you might also notice the problem in the page, and this is what I just talked about. I said, if you want to introduce a new problem, then you would insert a problem. If you want to introduce an additional page to the existing problem, then you would use the page, right? So, okay. So I want to show you a few things about the calculator, right? So here you might have noticed I have added a page. There are several ways to add a page. And this is another distinctive feature. You might hear me saying this very often, but this is something interesting as well. You can arrive at the same page or a same command in different ways. There are several approaches to get to the result that you want. So I've added an additional page here. And if I press menu, I want to use the calculator, all right? So I just want to show you a few things about the calculator first. Let us investigate, okay, what happens here on this page. Now, this calculator is menu driven. So what do I mean by that? Is that everything, when in doubt, refer to the menu. Since this is a calculator page, all the commands are for calculator use, right? So all these things I can do on this calculator page, and I'll explain what I mean. As Hassan explained, if you've opened up additional commands and you want to get rid of them, you just have to press escape, right? And press escape. So here is the menu. I want to show you what we can do with these few of these commands and few of these approaches. So I'm going to press, I'll try to add a fraction. So let's say I have 1. I'm going to write half plus 2/3. So if you want to navigate through fields, one of the ways is just to use tab, and then I'm going to add 2/3. So here, control and the division sign will give you the fraction symbol, and I want to do 2/3. So I can, just on the emulator, it's really quick to click on these on the screen itself, and that's what I'm doing. So you get 7/6, right? And if I'm interested in getting a fraction, all I have to do is again go to menu. Everything is available on the menu, and I go to number. And if you click on the number and I want to convert it to decimal, I convert it to decimal. You might have noticed that when I go to the menu, there are numbers here preceding the action. So instead of clicking here, I could also use the numbers to get to these commands. So this is how you can, this is just a very simple example that I have placed here. You can go back to doing a fraction. So if I want to go back to getting my result as a fraction, you might notice that there is a command which is number here, and you can approximate to fractions. And these are all various commands that you can use. So I'll go back to escape. Few other things that I want to show is the use of the sign, the degree and the radian mode. Okay, one of the new developments in this latest software, in the upgraded version, is this conversion, the degree and the radian. And it has been my experience as an examiner that students often kind of mess up on the degree and the radian thing. So this is right in their faces, right? This is just on the screen. So it is really encouraging for the students to watch out whether they're in degree or radian. So I'm going to function in radian, in degree for now, and then move on to radians. So this is the way that we can change from degree to radian. This is just really simple and very encouraging for students to be engaged in the mathematical work that they are doing. So I am going to use the trig key here. These are flyer menus. And if I go to the trig key here and I do sine, and now this is degrees, so I'm going to do sine of 30 and press enter, and you'd see I get a 0.5. I'm going to change this to a radian, all right? And let's say I am still interested in doing the sine of 30. So I go back here, I do sine. Now this is in radians. So if I use 30, there is one other way to force the calculator to answer in the degree mode. Though this is really simple, you could have just gone degrees, but I just want to show you the features. And then we can go back to the punctuation key here and click on the degree. So this instructs the calculator to work in the degree mode when it is still in the radian mode. And you can press enter and still get 0.5, right? The other thing that we can do is I'm going to kind of explore some of the other commands in this menu. And let's use algebra. Let's use numerical solve. Before I move on, I just want to point out that it is so easy to navigate through these commands, just in case I wanted to copy. So let me finish the nsolve and then demonstrate for you. So nsolve is used to solve, as the name suggests. And let us do an example, a really simple one. And I'm going to use fraction again. One other thing that is interesting is that you do not have to use x as your variable as long as you define it. So I'm going to do 2a minus 3. You can use tab. I just placed my cursor in the denominator by 5, let's say. Moving on, equal, since it's an equation, of course, you need an equal sign. Let me just add some complexity to it. So say, let's say minus control again, and I would like to do a over 2. So let's say a over 2. and equal to, I'm going to say 3a. Oops. You just have to delete and do a, comma, because you've got to define the variable for the calculator. And I'm going to write a here, and I am going to solve and press enter. Okay. And that's how you can solve and solve. Now, let's say the student has committed kind of an error. It wasn't 3a, it was 2a. All you have to do is navigate to the command and just press enter, right? And you can do your corrections. You can just scroll back. You can scroll back, and just if it were 2a, you can just rework the equation. So this is user friendly at in so many places. Let us do, so what are the other things that we can do with the calculator? Let's go on to the menu, and let's try and do solve a system of linear equations. Let's try that. System of linear equations. Here again, you do not have to stick to x and y. You could use a and b as long as these have been defined. So I'd like to say, number of equations is 2, and I'd like to use a and b just for demonstration. Of course, you can use x and y, and as to navigate through fields, use tab, and then you say okay, and we press enter, and then you have a template. These templates are also available in a different place under a menu, and I will get to that soon. So let's have those two equations. So I'm going to write 2a minus 3b, right, equals 0. And this is a plus b. Let me just write a plus b equals 1. And I press enter, and I've got the solution set here. So that's how you solve a system of linear equations. Let us do some polyroots. And let's go to menu and going to algebra, and I'm going to go to polynomial tools, and let's say it's a quadratic that I'm interested in. The real, you can also do complex. If you see here, you have the availability of the complex function here. I'm going to use real. Again, I can use tab. All right, I say okay, and I've got to write the coefficients of the term. So I'm going to say it is 2x squared. Let's go with minus 5. You might have noticed there are two different, this is negative and this is subtraction. So I'm going to use minus here, and this is 2. And I'm moving on to tab and pressing OK. And once this is done, you might have noticed when it is nsolve, you have an equal sign. When it is polyroots, it is just the equation, right? And I can press enter, and I do get the polyroots. Now, I do want to point out an interesting thing about the calculator here. Let's say I wanted to solve this equation. So I might go into nsolve and do numerical solve, and I'm going to use this equation, right? I'm going to copy paste. It's just like the computer. I'm going to press in here, and this time I'm going to say equal to 0. Right, and I've got to identify suggest the variable that I'm using, and I press solve. Okay, nsolve. I want to bring to your notice that nsolve produces one single result, usually the one that is closest to 0. Well, I can kind of lure the calculator to give me the second answer just by being a little tricky about it. I can go and copy above, and as I said, this is just have to go up and press enter. Oops. Right, and this time I will command the calculator to I'm going to suggest a restriction. So I'm going to control to get access to these keys, and this is such that, right? This is such that, and I'm saying that x is greater than, the greater than can be found in the same place here, greater than 0.5. Now press enter and you get your 2, right? So one other thing I do want to point out is the number of decimal places. If I go into the document and the document settings, here are the document settings, and you might see float 6, and I've had students lose a couple of marks here and there for inappropriate rounding, and the inappropriate rounding when carried forward results in inaccurate solutions, answers, and it's a worldwide symptom, if I can say that. Students just overlook the fact. So I generally tend to kind of get to their attention. And if I say, okay, if you do float 3, it does give you, and again, to navigate, you can use tab. And before I move on to the calculator screen, these are the settings where you have your radian, you have all these different choices available to you. And I'm going to go with float 3, and I'm going to press enter, and let us try and see what is happening now here. So I'm going to kind of use this one here. Let's say, so if I have to round it correctly, it should be 1.17, and let's do that. Okay, so what I'm going to do is go to the fraction here, 7/6, and I am pressing enter. And well, the other thing I could do is to, let me show you again. Okay, and here I could do control enter, and you get 1.17. So this is, if you have noticed, this is an approximation. It approximates. You do not have to navigate to the menu. These are frequently used commands, so you will have easy access them on the calculator itself. And you see this is 1.17. So this is kind of, these are strategies that we can use to train our students to be mindful and not to be careless. So these are calculator functions. I want to move on now to a few questions on the IB paper so that you see its direct application. The ones that we did really now in the short while before were easy, were really simple things that we could do. So just want to draw your attention to a question like this, where you have, and I want to show you how these questions can be effectively solved using the TI Inspire in a very economical way. So let us go ahead and solve this question. Now, you might have noticed I have moved on to a new problem, and this is what we have to encourage our students to use a new problem every time we are on a different question, because then there is no confusion about functions being defined or variables being stored. You can reuse the same variables and functions. So in this 3.1, I'm going to add a page. There are a couple of ways to do that. I will point out a couple right now. So you can, if you see the plus page here, it adds a page. So control and plus page will add an additional page to problem number 3. Alternatively, I could go to the doc, just the document. And if you see insert here, it gives me the choice to either do problem and page. So I'm not interested in a new problem right now. I'm interested in a new page. And this is how I can add a page. All right. Once you have opened a new page, of course, and this is what I called intuitive about the calculator, because it kind of instructs you, it guides you along the way and says, okay, now that you have opened a new page, what is it that you want me to do? And then since I'm interested in doing the calculator, I'm just going to add the calculator page, since we're still kind of exploring the calculator app. And let me store these variables. Some of our struggling students, this technique I find really effective with the students that struggle often with the cosine rule and the sine rule, and they do not know how to place. They have the access to the formula booklet, and I think they can make most of the fact that they can use the TI Inspire to store the variables and use the formula booklet to really have access to the formulae. So I'm going to store these as A as 10.6, and it'll just allow me to show you that. I'm going to say 10.6. And I'm going to store. You can store if you notice the store here, it's in blue. So to access the store function, I've got to do control variable, and I'm going to store it as A. And right. I'm going to store this. This has been stored already in the same problem. So I'm just going to enter. It is not going to affect us because A has been stored as 10.6 in the next page. So it really has no effect on this one. So, and the next one, A was 12.8. So I'm going to do 12.8. And I'm going to store it again as B, because students are really familiar with ABC because of the formulae, the variables in the formulae that are used are ABC. So I'm going to stick for ABC. You do not have to use ABC. You may use any that you would like. And I press enter. And the last one was 8.2, I believe. So it's 8.2. And I'm going to store it again as C. Right, and please enter. Okay, once I have entered these, this has been stored. And now I can really use the TI Inspires menu to go here, and I go to algebra to end solve. Let us refresh. Let us understand what the question was. The question was you have to find angle A. So it is the side, the angle opposite the side 10.6. So we've got to use the arms B and C. But students have sometimes hard time to kind of understand that. So we can use the formula directly. So I'm going to say A squared, because A has been stored. So I'm going to say A squared equals B squared. Oops, excuse me. Gives me an opportunity to show you that I can just go delete quickly. And here it is squared plus C squared minus 2 times B. And this is, I'm pretending to be a student right now, multiplied by cos of A. Now, you've already used A, so we've got to use theta. And it is in the trig menu. So I go here, and this is trig. And then, we can use theta, which is in the pi menu. So again, I want to get rid of this one. I accidentally use the punctuation menu, and I can escape. And I can go to this one, and I have the theta right here, right? This is in radians. I can quickly change it to degrees because my question you can also write it in radians, but I would like to show it to you in degrees and solve. And again, I've got to identify the variable I have used. So I'm going to write a comma and use the key here again for the theta. Once I'm done, I'm going to press enter. This is 55.6. Right. So it is so easy for students. Students often get confused with the sides and the angles, right? So all they have to do is train themselves to think about the use of the formula and the command in the TI Inspire. I'm going to address the other question as well here, and you can just use the in the same way, since we'll be running out of time, and there are some really fantastic features that I want to show you. So I'm just going to move on to the next one. I do want to, okay, so this is a question, a geometric sequence here, and I want to show you what you can do in the calculator. So again, I'm going to define this as a sequence. So once I can, again, this is 4.1. If you've noticed, we've moved from this apartment to this apartment, and I'm going to add an additional page. And this time I'm going to use another route. I'm going to say control doc. So it asks me which one to, I want to access. I say the calculator, and I am going to kind of define this now. So I'm going to say U1 U1, oops, delete is 1 and N. Okay, and I'm going to use a different, I'm going to show you a couple of different ways to define functions or sequences. And if you notice here, this one here, the symbol, I've got to access the control for this one. This defines the sequence that I'm about to kind of express. And it is 18 times 1/2. So 1/2 raised to n-1. And once I'm done, I press enter. So it's all done, right? And if now I want to solve, if I want to solve, again, the question says, less than 10 raised to -3. So I'm going to equate these two. I'm going in here and going to end solve. All right. And I'm sorry. Let me do that again. Try again. Yeah. And this is, now I don't have to, sometimes the equations are too long. This one is not. But in the event that they are long, this is an attempt to show you that we can just use the defined function right now. So I'm going to write U1n, just copy it from here, or I could have typed it. And it is equal to 10 raised to -3. So -3. And I am going to kind of define what I need to solve for. So again, this is n, because it is the n that I'm solving for, and I'm pressing enter. And here is the answer, right? It's 15. And again, remember, this document has been, we have adjusted the settings to float 3. If I wanted to see a larger, the digits, the remaining digits, all I have to do is copy the number here. Oops. Okay, so I can do second answer. I just want to show you, and press enter, and you can see the digits, the complementary digits of the decimal. Right. So, well, we haven't really answered the question. We just want to find out the nth term, which is less than 10 raised to -3. So what I can do is I can kind of just find out, because it tells me it is 15.1, and the students often get confused about that. So I'm going to find that the 15th term. All right. And again, what I can do is control enter, and right. And this tells you 0.01. But what we can do is I can press answer again and press enter. And actually it is less than, it is more than 10 raised to -3, right? It just shows you because I have done float 3, right? And it is a little more than 10 raised to -3. So all I have to do is find the 16th term. Okay. And in this cases, I think settings to float 6 are really useful. And I'm going to do 16, not 15. And then I can press here. And I can again do control answer to find oops. Another way. It gives me an opportunity to show you different ways. And if I go to menu and I go to number and I can convert to decimal and I press enter, right? So this tells you that this is much smaller than that one. So it is the 16th term. So students can really effectively use the calculator to find out. Of course, you can graph this, and we can also do it. There are different ways of doing it, but because time is a constraint, I'm just going to move on to some other features. Let us talk about the graphs features, because these are really very, very exciting ones. And I'm going to first start with a function that I have already pre-defined, and I'm just going to show you how to define functions here. You can go to tab, and press enter. This comes really with practice. This is really just comes very easy. The first time it may seem a little overwhelming, but once the advantages of the calculator far clearly outweigh the initial hiccups that you may have, you may feel, or you may think about. So I have already, so let me just show you. I have used tab. Okay, let me escape. Let me redo this. You go to tab. There's several ways to do this. I'm using tab, and this is the arrow. This is F3 of X. I'm interested in showing you where I have expressed the F1 and F2. So I go up, and this is my F2, and this is my F1. All right. I have restricted the domain, so you can restrict the domain. This is one of the features I wanted to show you. You can restrict the domain of the functions. And the other observation I have as an examiner is that students lose marks on sketching graphs because they do not pay attention to the domain restrictions. And this is how you can kind of insist or demonstrate or emphasize the importance of domain restrictions. And you can, I have the first F1x is x of x squared. And I move down, and you will see this, it is sine x. This is in radians. And I want to find, I want to do a few things about this. So that's what I'm going to show you next. And press enter. Get out of this one. I press tab again. Okay, I just click on the space, and you can get rid of the entry line. Okay, if you highlight on this one, you can see if I click on this one, you can get the graph. You can click on this one, you can get the equation of the graph. If you think the screen is getting too busy, you can get rid of them. All I have to do is this yet another feature. Within the menu, you have a contextual menu. Now the graph, the calculator understands you're in the graphing page, but then you need commands that are relevant to the current, the current page. So if you control menu, if you do control menu here or right click here, you have certain things that are really only applicable to the things that you're going to do here. So if I do control click, I can hide, right? I can hide the function. If I want to undo, let's say, I didn't want to do that. All you can do is control escape, and you get back the function. Let's do a few things here about the graph. I want to quickly share the features of the graph here. If you want to change the axes, all you have to do is double click here, and I can change. So let's say I really don't want this empty space. And this is really something that we need to emphasize to our students. Even when the IAs, the representation, it's easy. Those are things, if they pay attention to detail, they can score really well in those criteria. So we do not want empty space. And then, I can just say, okay, so I could have -1 and as the x min, and I can to navigate through the other endpoints, all you have to do is tab. Tab is really handy key, and if I wanted to change this, I would change. I would press tab again. It would move on to the X max, and I would move on and come back, and I can just press enter to get out of the tab functionality. And now there are so many things that you can do. You can change the color, you can change the thickness, you can add a dotted line, and there are so many other features. These are they add to the presentation, but there are some techniques that as teachers you might really enjoy. So I'm not going to go into detail about that. Let's see what we can do here. Let us go to menu. Let us analyze graph. And you can do the 0, minimum, maximum, intersection, find the derivative, the integral, and also all that sorts of things. So I am, and once you have done that, I might just show you the maximum. Okay, it gives you a prompt. You say, okay, because there are 2, it asks you, so you are going to kind of point out to the graph you're really interested in. And here again, very user-friendly thing. There is there is no scope for students to really falter here, because if you don't know what to do, this little thing tells you what to do here. It gives you a command. It says, okay, what you need to do is click the function graph and then click the left and the right search bounds. So it's like a tutorial for the students, and then I can go to the graph here, and this is the graph, and there might be multiple maxima and multiple minima. So this graph kind of, again, it draws attention to detail. It says, okay, which maximum are you interested in? And I click here and I go here, and this is my maximum, right? I want to show you a few other features, really, really interesting features. So I'm going to move on from this thing here. And let's say I want to kind of demonstrate something to the students about I want them to explore or to kind of investigate what happens with the maxima and the minima and the derivative of the function. So what I might do is I will go tab here, and since this is been in F2, I'm going to use the math template here. So this is the math template. It's a really useful thing. Everything is neatly tucked under this menu. So I want to use the derivative here, and my variable is X. And this kind of draws attention. Like every time the student gets through this, they understand the importance of identifying the variable, because that's really important. And then you talk about the F2, it is stored in F2. So I want to find the derivative of F2. All I have to do is do F2 of X. And you might notice that once this has been defined, it's kind of bold. So it's already been previously defined. And you do X, and I am going to press enter. And if you see the derivative, and this is such a neat and activity for as teachers, or as students, for them to explore. You can use different functions and talk to them about whether they notice something about the maximum and the minimum points and its relation to the derivative. I'm going to show you another cool thing about the graphs here. I'm going to menu. I can go to trace, and I can go to path plot, and I'm going to do the function. And if you see, and I'm going to kind of start the animation here, and if you see here at this point, you might want to draw their attention to the point what happens here. So I'm going to reset here. Okay, I'm going to kind of start, pause. Okay, and I might want to kind of start the animation again. And I'm going to pause at this point. And I can see the screen is getting busy. So I might want to kind of move these things before I show it to the students. And here I might want to point to them about the maximum, the relation of the maximum point and the value of 0 of the derivative. So these are really, it's kind of little neat activities that really kind of builds that conceptual understanding. And you can use different functions. I could have gone back and changed it to a different function and used it as well. I can do the escape, right? You can also, there are several things you can do. You can, I can trace all. So let's do trace all here. And if you see, I can just move it forward, and this can really at your own pace. And this allows for students understanding and exploration at their own pace. So this really, really supports differentiation, because the students can take their own time to explore once you have shown them how to do it. And then I can move on, and then maybe then reflect at this point. And then there goes the class discussion. Here's a teachable moment where we can just talk about what's happening and what would they think when it is a minimum, and have that those rich discussions around this concept. I'm going to move on to the next one. There are a few things that I want to really show you with graphing. So if I go back, yeah, so this is what I wanted to talk to you about, the axis features analysis, its dynamic nature. The entire thing is how dynamic. You can change things to notice whether there are patterns to it, We can graph relations, sequences, and I'm going to show you sliders. We just talked about the path plot and graph trace, and we'll talk about inverses and modeling. So I'm going to go on to the next one. This is a question, but I'm going to kind of not do that right now. I want to show you something about inverses, how, this is a learning tool as well as a teaching tool, right? There are certain times your students need some structure to instruction, and sometimes they can just explore. So I'm going to introduce a new problem, and I'm going to show you how. So we're going to do this. And I am going to the doc. I'm going to insert a problem this time, and I want to use graphs, right? And I'm going to do the very familiar one, y equals x squared, and enter. And I'm going to show you different ways of doing things here. And since we're talking about inverses, we want to mention its reflection, how it is a reflection over y equals x. So I'm going to go on and also graph the x, y equals x, because you want really the students to make that connection. And you'd see, you want to kind of emphasize or reinforce the idea that the domain and the range, they interchange. So let me do one thing here. Let me kind of go on to menu. Let me go to geometry and points and lines, and there is a point on. This is construction. So I'm going to click on this graph, and I'm going to have a point. Once you are in this, and again, here it's so easy. If you do forget what to do and how to go about, there are instructions here. It's a manual for you, for students as well. And then I need to escape. Okay, and then I'm going to kind of click on here, and I'm going to write, I want to use 2. You might see that how this will, once I change the 2, because it's a point on the graph, with my input of 2, it will give you the output of 4 as your y value. All right. Again, there's so many things that I want to share, but it's the time is really short, so I'm going to show you this little thing here. And then, so let us reflect this point. And what I'm going to do is go to menu, okay, geometry, and I'm going to go to the transformation and going to reflect, right? So I'm going to reflect this. There's one thing I need to do before. So let me control escape, all right? And let me escape here. Before I do this, this line, it does not reflect a point across a function. So I need to create a line. So I'm going to quickly draw a line. So you go to menu, you go to geometry, and I'm interested in doing a line. And here is a line. I'm going to draw a line because that's a function and I want to create a line. So I'm just going to draw a line here again. I'm going to get rid of the tool that I used. And now I'm going to reflect that point. And here I'm going to go to geometry, and you go to transformation, and you go to reflection. And you're reflecting across this line, this point, and you get a reflection point. And now let's see, and again, I go to escape because I have this is getting in the way. So I'm going to just lift it and tuck it in a corner here. And this is a point. Now I'm going to do something interesting. Going on to menu, I'm going to trace, and I'm going to geometry trace this point, okay? And let's see what it does. So if you see the geometry trace here, and now I'm going to click this. I'm going to take this point and hold on. Oops. So if you see, what I'm doing is I've traced the point. So this is the student's first introduction to the concept of inverses. And you say, yeah, if it is a reflection across the y equals line, this is what the graph looks like. And of course, you can have those discussions about restricting domain, how the inverses have to be one-to-one function. And you can talk about which branch of the function really corresponds to the inverse and have all those discussions. I'm going to show you one other quick way of doing this before I show you data capture, which is really very interesting. So I can control click, go back. I can escape here, and I go to menu and I go to geometry. Oh, sorry, trace, wasn't it? And I erase the geometry trace. Okay, right? And one other fun thing that I can show you is, and of course, I need to get out of the geometry trace so I can escape back. Now, one other graphing feature. So let me do the tab and just draw your attention to this one here. This is the first one is written in terms of y, and the inverses would be written as x of f1y. So I'm going to kind of go on menu, actions, the same. You can just do it in so many different ways, and that's the beauty of the thing. And I'm going to write this as x. So equals, f1 of y and press enter. And if I just kind of move this, I again have to get rid of the tool that I'm in. I lift this up and I put this on the x-axis, and here you have your inverse. All I can do is go back up and change the function. So I can go back here, tab, and go back here and up, and I can just write this as x cubed plus 2, and press enter. There you have your inverse, and this is how it doesn't. You don't really have polynomials. You can use exponential functions as well, and you'd still. Let me just do that. Let me just demonstrate that. Go to tab, go up. Escape, and I can go tab and go up, and instead of this I can just have e raised to x. So let me just do e raised to x function here, and I press enter because this was defined in terms of the function, and that is why you have got and students can explore by themselves. Think about inverses when you're teaching them inverse trig functions. This is really a cool a short little activity that students can really explore by themselves. I'm going to move on to data capture. This is how you do modeling. And, if we have a webinar next, we can talk about modeling different functions. I'm going to show you one little thing about data capture, why it is such a cool thing. So I'm going to open up a new problem. Okay, so I'm going to open a new problem. And I'm going to insert a problem because we are doing something new, and I'm going to place a calculator here. Oh, sorry. So again, if I didn't want a calculator, all I could do is escape. You press menu again, and I'm interested in a graph. And this time again, just for convenience sake, and I'm going to do x squared and press enter, right? And now I'm going to identify here a point. So I go to point on, I go to geometry, points and lines, and I do a point on, and I'm going to kind of, again, click here. Again, I have to get rid of the tool. And now in this place here, again, you can, I'm going to kind of draw a tangent at the point, points and lines, and I'm going to draw a tangent. So again, instructions you'll find in the tool, and I'm drawing a point and a tangent here, and yeah, and this is overlapping. So I'm just going to place this here, and this is the tangent at the point. If you are going to move, you will see that it changes. It is dynamic, and this is the dynamic nature of the Inspire. Okay, now what I'm going to do is kind of just pull this here, just kind of take this, and I'm going to kind of go to geometry, and I am going to measure the slope. I'm going to measure the slope. Well, it's clear the slope is here, but there's something that I need to do. I do not need this, so I can hide this. I'm just going to put this in the corner, and I'm going to kind of now escape. I'm going to store this as my x coordinate. So I'm going to call it xc, right, and press enter. And I'm going to store this. And if I say, so this is the contextual menu, store it as a gradient. So I'm going to call it gr. Okay, and I'm going to press enter. Now you might notice that this is bold emboldened because this has been kind of defined. Now what I do is, what I'm going to do is going to open an additional page, and I'm going to open an additional page. And this time, since we've not done lists and spreadsheets, I'm going to open a list and spreadsheets, and I'm going to just write here, identify it as the X well. These are all the X values, and I'm going to call this the G values, which are the gradient values. Okay, and yeah, okay, all right. And now I'm going to data capture. What does it mean by data capture? The moment I try and move this point, it is going to capture all the X coordinates and all the gradients. And this is a neat little activity when you are doing derivatives, you're possibly introducing them. And then I'm going to menu, and if you see data, and I'm going to data capture and automatic. And this time I'm going to grab all the X values, and my X values have been defined by XC. So if you go to variables, you will see all this has been defined here. I'm going to use XC, and I'm going to enter. This is the value. This is the X value that is already on the screen, 2.03. I'm also going to do the data capture for the gradient values, and I'm going to go to the menu, do the data capture again, automatic. And if you go to variables, I just want to remind you, it has been defined by GR. So all I'm going to do is click on this one. So this is, and then press enter. Now, once I move this, okay, this is what I want to show you. So now what I can do is I am going to open another page here, okay, additional page, and I am going to control doc, and I'm going to use a data and statistics page here, and I'm going to click here. I'm going to do the XVal, and this is what you see, truly the dynamic nature of the calculator. And this is your X values and your Y values are here, okay? And now what I'm going to do is I need you to be looking at the changes that is happening here with the 10.3. So all that is changing with the when I'm moving this point, this coordinate, I want you to be able, students to be able to see the changes that are happening here. So I can go and move this here. Okay, this is your layout. And this one this one, since I'm trying to move it to the left, So it is okay. And now when I click here, I want to group this. And now if you see what I mean. I have this kind of neatly kind of grouped. So any changes that I see here will be recorded in the spreadsheet, but it's behind the scenes kind of thing. And let us see what happens. So I move the point, and if you see here, you see the change. And this is empowering for the students, because when they see that the slope, the relations of the gradient to the derivative, when they begin to see, and you can change the x squared to the x cubed or any other function that you want. And this is really, really empowering. So I've gone above my time. My apologies to Mr. Sanjeev. But this was really tempting. I wanted to show data capture. Thank you, guys. If there are questions, please forward them my way.
Thank you, Shadanak ma'am. Participants, if you have any question, meanwhile you can ask the question to the Shadanak. Meanwhile, Sanjeev will be preparing for his presentation. So if anybody has any question, they can raise your hand. I'll unmute them.
I would begin, I would tend to think that this is so much combed into one session. If this has been your just your first experience, it might just be too much to absorb, and that's fine. We've been doing this for a longer time, and but I hope you have seen the power and the intuitiveness, and the how it can help students on their math exploration. Yeah. Do I have any questions?
Yeah, I just want to ask, comparing to Casio, what would you say about Zoom auto feature of TI Inspire? The Zoom auto feature. There is we have
there are several functions here which we have not been able to get to.
Okay.
So you can go to Zoom, and there are all these functions.
Okay.
Yeah, there are several. You can Zoom box. I want to show you what Zoom box does. If you really want to focus, like, let's say, so I just want to focus on this point. All I have to do is pick a corner and do this. And if you see, it just zooms that part. So you've got several functions there. You just have to explore, and
Okay.
I think we have just scratched the surface.
Surface, yeah. Okay, fine.
Yeah.
Good.
Right. Thank you.
Thank you.
So it might be a good idea to also share the Google form if there are particular
ma'am, that we will do in the end of the session, the complete webinar. You can stop sharing your screen, ma'am, now. I think.
Sure.
All right, I'll get started, and I'm guessing you can hear me and see my screen as well.
Yes, we can see your screen, sir.
So this session basically is focusing on TI Inspire, the CX2, the CAS, and the non-CAS version. So the white one you see is the CX2, that's the non-CAS, and the blue is the CAS. So the section I'm actually focusing on really does not matter whether it's the CAS or the non-CAS, because I'm going to be talking more about widgets than programming and STEM and so on. So it doesn't matter which section of the CAS section, which of the calculator or the devices they use. Okay. So what I'm going to go through is an introduction to widgets, then what are user-defined functions, and then the various programming options that we have got on the TI Inspire. So you can do scripting in Lua. You can write your code in TI Basic or in Python. Then I will introduce you to the teacher software, which also incorporates the Navigator. So the teacher software is the premium version, which now is the default version. And we've got some activities on STEM. Obviously, that would be time dependent on how much I can cover. So to introduce you a widget is a very powerful way of responding to certain questions in an examination. And whether it's the IB or non-IB, or when I say IB, the non-CAS or CAS, you can define widgets. And a widget is basically a single page application. You can have 2 or 3 pages, but then it needs to be grouped into one single page. So Shraddha did show you the option of grouping, and you can create widgets. Now, if you see, I've got a demo over there. I just enter the coordinate points, and by entering the coordinate points, what it will do is it will give me the slope, the distance as an exact value, approximate value. It will give me the equation in the form y equals mx plus c. And also it gives me the equation in the form ax plus by plus c equals 0. So if I can just escape and probably open a calculator page there. So because it's a widget that I have defined and I've stored it, I can actually, I'll probably just insert a new problem so we don't confuse. I can go into the section add widget, and I've got all these widgets that I have created. So I'm just going to look at this particular widget, which I've just called coordinate geometry 2, but you can see I've created a whole lot of widgets. So probably I'll just use that standard one there. And as you see, it looks very complicated, but if I do Control A, and if I just say actions, and if I say evaluate selection, you'll see basically it gives the information that I'm interested in. Now I can go and change any of these points. So let's change that to 5. And if I just click enter, you will see it basically updates the slope, the distance equation, and so on. So it's more like writing a code, but I actually haven't written a code. I've just defined all the functions that are available on the calculator. So if I click any of them, you can see that's the function I've defined, and that's the slope. And I've hidden that bit and I'm only displaying the answers. So all of them are basically calculator syntax that pre-exists. So there's no code that you are writing. And I can change any of these points. If I go and change that to say -13, you'll see it updates everything. So that's just a widget that I have introduced you to. And I've got several widgets, so I'm not going to demonstrate each one of them. But if I just go back to my PowerPoint, you'll see I've got another widget, which Shraddha was talking about, finding the inverse of a function. So I can define the function here, and it gives me the domain for the function, and it writes out the function in the form y equals this. And then what it also does is with the widget, it gives me the domain of the inverse, and it gives the function there. And if the domain is not displayed, then basically what it is telling you, the domain is all real numbers in that case. So this is another widget that I have created. And this one here is for transformation of functions. I've got a question: what transformation will take the function over here, which is basically in the proper fraction form or rational form? And I wanted to give me the hyperbola function 1 over x. So I've got all the dilations and so on, and I can try them. But as I said, I'm running out of time, so I will not basically be demonstrating this. But if you actually want to see how to create widgets and what widgets can do, I will send you a link later on, or I'll give it to Revti, and she can share some of the videos that I've done on just creating the widgets exclusively. And also, you can look at writing programs in TI Basic or Python if you're interested in coding. So I don't want to write codes and spend time doing that today. I'm just demonstrating more on what the TI Inspire can do. So the power of the TI Inspire is really the focus for the session. So this over here is another widget that I have created, and it's actually one application, but you can see over here 2 pages are grouped together. One on the left is basically a notes page, and a notes page is actually one of the most powerful applications of the TI Inspire, because you can actually add text to it, you can do mathematical calculations, and it's a very dynamic page. It talks to every single application that you've got on the TI Inspire. And of course, you can do things like add sliders and define functions there. So, interestingly, the most frequently used application for me is actually the notes page rather than the calculator page. And in this particular case, you see on the right, I have got over here, the red one obviously is the derivative that I have got. And you can see the blue, the blue is the derivative, and the red is the function that I have got. So I've defined the function, and it's giving me the derivative. So in fact, I've just got the colors mixed up. So my base function is really the log function, which is the blue one, and the red obviously is the derivative for that. Okay, so this is another widget for writing the inverse. So you could do that in a few different ways. So I've got a log function, and I know that the inverse will be an exponential function, and you will see it always gives me the domain for the inverse. So widgets are pretty helpful. This I've just got some X values and Y values in the list and spreadsheet page, and I've created a widget which only gives me the correlation value and the coefficient of determination, so R and R square. And looking at these values, it is telling me that this is the best transformation, because R square is 0.99, so that's 99.9% is the value of the coefficient of determination. So all these are calculated together in one go. So rather than doing one at a time, if you kind of pre-create a widget, it's pretty helpful. This one is on kinematics. So it's got a position time equation, but it gives me the velocity, it gives me the acceleration in the widget. This one here is, now I'm moving on from widgets to user defined functions. So again, something very similar, but over here, instead of a widget, I have created a function and I've defined the function, and it's going to do exactly the same thing. It gives me the slope, the distance, the approximate distance, and the equation. So I'll probably just demonstrate how I can access this, because I'm saying I have actually stored this. So if I click escape now and go to my calculator, and if I click on the book menu, you will see it gives, I've got all these options, but if I go to the last tab, which is number 6, it's got my user defined functions or whatever I've defined. So I'm going to look at the user defined function coordinate geometry that I created. And that should probably have been on another page. So just so that I don't mess up things. So insert a new calculator page, and now if I click on the book menu and user defined, and if I just go here, and now it's going to ask me the input. Now when I was on that page, I had defined the function with 2 points a and b. So let's just go and put x1, let's say is 2, then comma, and let's go and put y1 as 5. And so that's my first point, and the second point 6, and comma, let's say 9. And if I click that, it gives me the slope, it gives me the distance and equation. Now this one is not a widget, and I call this as a user defined function. And with okay, I just want to show you how to add a widget. I've probably missed that. If I just go into a control doc, which is adding a page, the other way is to just do control I. So control I is insert, so control and then the letter I, and you'll see it's got an option over there, add a widget, and then it shows all the widgets that I have got. So the good thing about a widget is I could be working in any problem. I can access the widgets that I have defined. So I don't have to be in a particular document. I can have 10,000 documents open, and I can still access a widget that I have stored. And the same is with the user defined functions. So that's basically what widgets are and user defined functions. So back to screen here. This one is on asymptotes for a rational function, and you'll see I've created a widget, and that's the input I'm giving in there. And what the CAS is doing, or what the calculator is doing, it's giving me the expression in the proper fraction form. So the right hand side, which is not under the denominator, that's the quotient. 6 is my remainder. It's giving me where is this function defined. It's giving me the vertical asymptotes, it's giving me the other asymptotes, it's giving me the x-intercept and the y-intercept. So it actually gives me basically everything that I want to see. So probably a part of my screen is getting cut, but you should be able to see most of it anyway. And all I need to do is just go and change my rational function, and it will update this automatically. And I have actually got another screen for this. When I do the user defined function, I have actually created a function in the background which will go and graph it for me, including the asymptote. So I'm going to skip that bit, but it can be done as well. So you can actually simultaneously graph this function. Okay, I'll move on to the programming option that the calculator offers. So the first of the programming options is in BASIC, and that's the original programming language. You know, BASIC was the first programming language. So TI has got its own version, which is the TI BASIC. And most people basically write their first code in BASIC, and then they move on to other programming languages. But I must say that the base and the basis for any programming language is actually BASIC. So we are going to look at the TI BASIC version. So whether you're using the TI-84, the TI-inspired CAS CX or CX2, you know, all of them basically have got the same programming option, which is in TI BASIC. And I have got a link for you, and I will share this PowerPoint so you can actually access these links. So it's got a section which is called 10 minutes of coding. So for people who are writing codes in TI BASIC for the first time, if they go through this link, it shows them what are some of the essentials of writing code and what are some of the things that you could probably do. And once you have actually moved on to this, or you have done this, you can move to the next level, and that would be basically using the loops and so on. Okay, so I can go and if I click menu or Control I, so I've got the screen capture here. It says, you've got various options of adding a calculator and widget or whatever. But at this stage now, I'm interested in writing a program. So that's adding a program editor. And I said new, and it opens up this menu box or a dialog box. So I give my program a name for today's presentation. I'm just calling it program 1. Now, in a drop down, I've got two options. One is called a program and the other is called a function. And I'll in a moment talk about what's the difference between a program and a function. But let's say this is a program and I want to be able to access this all the time. It doesn't matter, whether I'm doing a problem on matrices or probably anything. At some stage I may need to access a program, so I can access it from anywhere. So it doesn't have to be in a specific document. So if I give it a library access, that means it will start showing in the catalog. And it is important, if I'm wanting to use programs and kind of demonstrate that, I actually give library access as well. So these are some of the built-ins that we have got for coding. So, all the controls over there, the loops and various conditions. You've got the input and output over there, the mode, and I'll just share a few other screens with you. So that's basically all the controls for writing the code. But if you look at this one, I've got the input and output. I stands for input and O is the output. I can get the user to actually input information. So that's the request option. I could display the information, on the screen. I can display the information at a given point and so on. So those are all the inputs and outputs. Then the mode for the calculator, the digits I want to display in my program, the angle notation that I want to use, degrees, radians or gradients, the exponential format, whether I want the answer in the real or complex form, whether I want answer in the approximate value, then basically a whole lot of other things as well. And then there are especially if you're doing STEM, and there is this option to code with the TI Innovator Hub and the TI Rover. So just when you click on the hub, it gives you whether it's the hub commands or the Rover commands that you are inputting. And of course, you can see over there, I've got an evaluate command, especially if I'm using variables and parameters, I'll be using the evaluate command very often. Then there is obviously a drawing option, and I'll probably demonstrate that when I'm doing Python, but you can do actually drawings with the basic as well, TI basic. So I quite enjoy programming, and I actually write programs in all three options that the CAS has, the Lua, then the basic and Python. But Python is newly introduced, and obviously you'll find it much user-friendly and quicker. So I tend to write most of my programs in Python, but I always suggest before moving on to Python, it is best to write a few programs in TI basic. That's a good starting point. So I'm just going to give you a sample of code that we have written in TI basic over here. We are rolling a dice. So it's going to ask the user how many inputs. So this is the complete code I have actually given. So maybe if you just use this code and you first run your program, it should work fine for you. But I'm actually going to run a couple of programs now, just to give you an idea. Okay, so I'm going to open my file and yeah, okay. So if I just change escape from here, and if I go to some other page, TI program update. Okay, it's not letting me navigate further. Actually, this is blocking my screen, so I'll probably come back to this later on. Let's see if I can access it another way. All right, so that's probably a good way to go. So I'm going to run the program, and to run the program, all I need to do is do Control R. So that's my program. So I've defined the program. It is called rolling a dice, and you'll see there's the opening tag program, and then all my code goes in there. and then it has to end the program. So let's go and run this program, Control R. And how many sides does the dice have? So I can have 8 sides or any sides, but I will go by the standard dice 6. So you will see this is requesting an input from the user. So if you look at the side of my screen, it says request how many sides does the dice have. Now that's a user input, okay, and it's going to be stored. And dice 1 gives me 6, dice 2 gives me 6. The total of them is 12. So if I do again, if I run this program again, and let's just do probably 8 sides. And so it's given me 2 and 5 this time, and this total for both is 7. So I've just simulated a rolling of a dice. That was the program. I'm going to go to another program over here. Let's say you're familiar with bisection method, Newton's intersecting lines. I'll just do probably something, just the quadratic one. So it needs basically the value of A, B, and C. So let's run this program. So let's say 2 and -3, and let's say 5. And it basically runs the program. It gives me the discriminant is negative. It says no solution. It gives me the turning points, the equation in the turning point form. So basically, that's a program that I've written. And if obviously it had solutions, if it, I could actually go into the complex mode and get the solutions, but if it had solutions, it would give me the solutions as well. So that was just another program. I'll skip the intersecting lines. And okay, that's bisection method of finding approximate Newton's method. Let's see, rolling a dice. This one probably is helpful. So this is going to give you all the information about a triangle. So it's got everything programmed into it, the cos rule, the sine rule, the area, and so on. So all it needs is the triangle basically has 3 sides and 3 angles. So when you see the letter A, it's talking of the angle. So side A, B, and C. So let's run this program. And it says enter the value for side A. So I'll put 0, and 0 means I don't know that. Enter the angle. So let's put that at 30 degrees. And enter the value for side B. So let's say that's 7. And let's put that as 0, unknown. And let's put that as 0, unknown as well. And then finally enter the angle C. So let's put that as 60. And let's run it. Invalid program reference. So basically, I think the information that I gave didn't match up, but I can run this again. And what it will do is it will give me the area. So if I just go back to the last bit over here in my program, what it is going to display is the area. It's going to give me the sides, side A, side B, side C. It's going to give me angle A, angle B, angle C. So just being mindful of the time, I won't try to run it again, but it works beautifully, the program, especially if you have a question in the exam where it's asking to do things, then the information is there. You basically enter them as it is. So what is not known to you, you just enter that as 0. So if I show you, I've run this before and you can see that over there. So that's how the program will display the information. Side A, side B, side C, it's giving me the lengths and it's giving me angle A, angle B, angle C, and it gives me the area. So that's just a program that we have written in BASIC. All right, so I'll move back to my PowerPoint. Okay. So this screen on the right is explaining the difference between a function and a program. So a program can have a series of code, and as you saw, it can run into several lines. I can have multiple inputs from the user, or I could create those inputs as variables, and I could also have multiple outputs. I can use logic over there. I can use the if or the when command, and I can have loops over there. So the loop in the TI basic is basically a for loop or a when loop. So I could introduce as many loops in my program. Whereas in a function, basically I can't have multiple lines of code. All I need to do is give it a specified input, and it will give me the output that I am requiring. So an example of a function would be if I want the domain, I enter the function and I define the rule for the domain, it will give me the domain. Likewise, if I want the inverse, it will give me only the inverse, but I can't do multiple things with it. So it basically is defined to return a specific output from a supplied input. So the input could be an equation, it could be a parameter or whatever. And obviously when I'm writing the function, I need to supply a syntax or a mathematical rule there. So when I am writing a function, you'll see I've got the function starting and the end function, and my request or whatever I'm putting for the function will go in there, and within that there will be an option called return, and that would be the output. So functions are basically generally 4 or 5 lines, whereas a program can be multiple lines. So that's a function that I've written over there. So you'll see it's going to return the slope and it's going to return the distance. So that's where I've defined that. So in this function, I'm going to define the coordinates of the first point, x1, y1, and coordinates of the second point. And it just, I've used the return and I've written the formula. And I've just put this because I wanted 2 displays. I put it in a matrix. If I just wanted the slope, then I didn't have to do that matrix over there. So that's just an example of a function. Whereas when I'm writing a program, I have just called this as try2, the program, and the code goes here. So this is the coding section, and I could have several lines of code and several inputs and several loops. But a good way is to start with, single loops and so on, rather than working with multiple loops. And once you have written a program or a few programs, you'll actually want to write more and more, and you'll get probably more proficient in writing programs. Okay, so next I move to to conclude with basic. Again, if you go to the TI website, you'll find over there are certain, if you go to the 10 minutes of coding, it will actually help you. And once you have done that bit, then I suggest you move to variables and parameters, and then you go into the conditional statements like if and then, or the loops, and you will start enjoying, the coding over there. Okay, I won't go through Lua, but actually I'll just demonstrate what you could do with Lua. Lua is actually very powerful, and it's a fast programming language. And we use it basically for images, image processing, or games or web applications. So what I may do is just show you something that we have in Lua there. And I will open one of them here. So this is actually a screen, and probably not this one. I want to go to another one. I'm just finding this very annoying, the menu that's blocking my screen. I don't think you can see it, but I want to get to the next one. So I'll just close this. So maybe it should bring up the next one. It's not letting me. Okay, let's try and do this one here. I should be able to move this, zoom menu down here because it's blocking all my controls. Okay, let's see if I can minimize it or do something. I'll try and probably run it through. It's over here because I wanted to show you what I could do in Lua. And obviously it's not the, okay, I'll probably try and demonstrate from here. So this is actually done in Lua, and I'll run this program over here. So you'll actually see the cyclist moving. Now this is what I was saying. You see the cyclist moving, and it's giving you the potential energy, kinetic energy, the velocity, and everything. Now this is a program that's been written in Lua, and these are dynamic. So if I reset and I run it again, and I can change the coefficient of friction, and let's run it again, and you can see how the energy levels change. So this is done in Lua, and Lua is very powerful with graphics and images. Okay, if I have the time, I'll come back to some of these later on, but I just want to demonstrate this With the teacher software, you also have the opportunity to create quizzes and questions. So I'll be talking about that probably when I'm demonstrating the teacher software. So let's get back to my PowerPoint. And yeah. So when you add a Lua script, you'll obviously have to enter the title for the script, and the programming page looks slightly different. And then it gives you the output there when you run the script over there. So suspend script, run script, and you can run the script over here, and it just gives you the output there. So Lua is very different from Basic, but it's probably more advanced. And once you've got the basic knowledge on using the Basic, then probably you can move to Lua. Okay. Okay, so moving on to Python. Now, this is the most recently added programming interface with the TI Inspire, and it's very, very neat. So again, this demonstrates, when you do Control I. So we had looked at adding all those applications, but right at the bottom, it says add Python. And when you add Python, obviously it will ask you to give it a name the first time you write that. So program 1, and you can use, the various modules. Now, one of the things that I want to mention, it works more efficiently in the handheld view and not the computer view. And to quickly change between the views, if you do Alt Shift and H, that's the handheld view. And if you do Alt Shift and C, that's the computer view. So Python works beautifully when you are actually in the handheld view. And I'll demonstrate that in a moment. So let's go and look at some programs in Python. And okay, so let's look at, I'm going to skip the quadratic formula because I did that in Basic, but let's look at probably shapes and colors. So it's got the built-in module. So I'm using the TI draw module, and I don't know why I've got that twice. I don't need it twice. I just need it once. And if I run the program, it's run the program, and it's given me this. So if I go into the essentials of the code, it's basically saying get the screen size and set colors and fill arcs. So I'm actually doing arcs, and they're going from 0 to 360 degrees. And I've just used 3 different arcs over there, and it does that. And the output is always given on a different page. We call that as the shell page. So that's where it actually gives the output. So 318 by 212 were the dimensions for the page. Let's run another one, heads or tails. So let's run this. Now this is in Python. So Control R, enter C for coin or D for dice. So I could actually do either of them. So let's do coin, and number of times I want to toss it, let's say 7 times, and it gives me the output. So the first time I got a head, tail, head, tail, tail, and so on. And if I do Control R again, and let's do a dice this time, and number of times, so let's do 4 times, and it gives me, I got the number 5, the first roll 6, 4, 3. So this is all done in Python. And let's do this one here. I'm going to run this, enter a number up to 1,000. So I'm going to simulate this, say 500 times. So 500 is my number. So it's a dice that I have rolled. So I got the number 1 90 times, number 2 85 times, and if I add all these, they should add up to 500. But the good thing about this is, of course, it's given me the count over there for each of these. So this was rolling a dice. But if I go to the next page, it puts the information into a list and spreadsheet page. And further down, it gives me a pie chart as well. And because the probability of getting, the number 1, the number 2 is very similar. So if you look at the percentages, they are very similar as expected. And I could actually go and, okay. So the idea of demonstrating this was, although I'm writing the program in Python, the information it is outputting is still available for me in a list and spreadsheet page, in a data and statistics page, or wherever I want that. So I can get that information straight away from there. Let's look at another program. This is a nice one. It's called the archery competition. And in the program, first I need to put who are the competitors here. So I can change the names there. So let's just go and make Shraddha as one of our participants, and let's probably put Revati there. Okay, I won't bother changing the other. So it's 4 competitors. I can have more. I can have any number. So I'm running this program. So that's Shraddha's, and so she's at 4 strikes, now 5. It gives now Revati's striking. So this is all in Python, and I could run it faster. I've just slowed it down to a second for between each. That's Roger, and finally Harry. And that's finished. And now if I click exit, it gives me who the winner was. So Shraddha is the winner, followed by Harry, then Roger, and then unfortunately Revati, sorry for you, you finished last. But maybe if I run it again, you can probably finish before. So it gives you the running total and everything. So that's again in Python. And then colored arcs, let's run that as well. So primary and secondary colors, escape. And so these are all basically in Python. So you can actually do some tricks with primary, secondary colors, and it will run through. Okay. Escape, just demonstrating a few. So let's run this one. So the red color with changing intensity from 0 to 255, the green, the blue, so the 3 primary colors, and now these are the secondary colors with varying intensity, and then all 3 colors mixed together to give you white. So again, a very good STEM class demo, and probably just do one more. Let's run this one. Come on. Okay. So just random colors. So if I do this again, so it's like, you know, going to a hardware store and selecting the color for painting your wall. So if I run it again, it will give me a different set of colors. So it's not going to give me the same set of colors every time I run this. So now it's given me different. So these are all written in Python. Okay, so coming back now to my presentation. So I'll skip all these bits about Python now because I've demonstrated that, and again, we are hard pressed for time. So basically to run the program, all you do is Control R. Okay. So Python has got all these built-ins, and I just want to talk about number 7 and 8, the hub and the rover. Some of you probably may have had a look at the hub. So the hub can be connected to the handheld, it can be connected to the computer, and the rover is basically you can put a hub into the rover, and then you can do a whole lot of codes with the rover. So I've done, you know, automated driving with the rover. It's like the autonomous cars and automated parking, and you know, it senses basically things around it. It slows down, stops, changes its path. And with the hub, of course, you can have various inputs and outputs. So you can have light as an input or output, you can have sound, and a whole lot of things. So if you are into STEM, you will love using the hub and the rover. And you'll see at the end of my presentation, I've done about over 100 STEM lessons with the hub and the rover. Okay. So I'm going to skip all that now for the time being, because these will be available to you anyway. It's just telling you how we could access everything for coding in Python. It may look very kind of overwhelming, but once you've done it a few times, you'll actually find it's not that difficult. It's pretty straightforward. Okay, skip all that. This basically is giving you a comparison between basic and Python, but if you're going to be a TI user, it's good to code in both. And Python has certain advantages over basic, but I always say for a starter, you should always start with basic. So it's given all the differences in the code. So the PowerPoint does explain that. I'm going to skip through all those. And there are certain key features for Python, and also now they apply for basic. So auto indenting, the syntax highlighting, everything happens on its own, and it uses different colors. So it just makes it so much easier for the user to write the code. Okay. I want to talk about the Navigator hardware and the software. The software is the part of the TI Inspire teacher software. Would anyone tell me how much time do I have remaining?
You still have 10 minutes.
Okay, all right, that's great. So that's the Navigator hardware. So that's the access point which actually creates a wireless connection, and the wireless adapters go on top of the calculator. So these are the heads. And if you examine the calculator, you will see there's a provision for these yellow caps to go in there. So once the yellow caps are connected to the calculator and this access point is switched on, you have actually created a wireless network. And you can go into settings and connect to the wireless network. Once you have done that, you actually have 40, 50, as many calculators talking to the access point. And if you are using the Navigator software, then you actually can see all the 40, 50 calculators that are connected. You can give the students control. You can send them files. So the software is the teacher software, which is a default version now. So even if you don't have the Navigator hardware, you still have the teacher software. And the current version is 5.2. This screen just displays the hardware and the system setup, which again probably is pretty straightforward. So what are the features of the Navigator software? You can create questions and quiz in various forms. You can create and run polls, live polls, and so on. You can make the student or any participant a live presenter. That means they're doing things on their handheld, but everyone in the class can see that if you want. It's an opportunity for all the 40 or 50 people who are sitting in the room to collaborate. From the Navigator software, you can actually manage the handheld. So you can send them into press to test mode. You can transfer files, or you can change the mode settings for everyone. If you want everybody to be in radians, you can control it from there. If you want them all to be in, float 6, you can actually manage the handhelds for everyone from there. You can do screen captures. Now, if you're doing quiz, you can also do auto grading if you supply the answer. And if the student gets it wrong, it also gives a feedback as to where they would have made a mistake. Then you can create a student portfolio for every class that you have. And it's a fantastic place to share files and documents, and the quickest way to upgrade the student handled. So if they're on version 5.1 and you want all of them to go on 5.2, once they're connected to the Navigator software, you can in one go upgrade all the handhelds. So this screen is just displaying how I could create a question answer template. So you can see I have an option of multiple choice, open response, equations and expressions, coordinates and images, and so on. Excuse me. And I've just created a multiple choice question. The student selects the answer, and if the student gets it right, it will give a mark. Otherwise, it will actually tell them what's the correct answer. And if there are more than 2 ways of expressing an answer, you can enter all those so the student can see that the answer can be expressed in a few different forms. And if you have given, 10, 12, whatever number of questions, it will assess the students for all those questions and then create a marking, not a marking grade, a grade book, and then a student portfolio. So you can actually do 7 or 8 quizzes over 2 months, 3 months, and then see how they have progressed. So it's a wonderful place to create student portfolios. And this over here is just showing you some of the question properties that you can control through the Navigator software. So this is just a display of the teacher software. So you'll see over there, I've got class, and I can create classes over there. And once this class is running, I will be using that tab, and I can end, start, or stop a class from there. And this over here are the students in my class that I have added over here. I can add any number of students and give the class a name. So these are two different screens that I've captured. And this is all in the Navigator software. So normally when I'm using my teacher's software without the Navigator, I'll be on the Documents tab. And when I'm running a class, I could basically swap between Documents and the Class tab. And if I go to the Portfolio tab, it will show me how the students have performed over, you know, a term or whatever. So this is just showing you the class. So on the right hand side, you can see I have the option to pause a class, end a class, or start a class. And this side, if I want to send files to the class, I just click that. If I want to collect the files from their handhelds, collect, so I'll be using that option there. And if I want to send files to them, I can select any of these files and send it to the students. So just under the class option, you see all those options. And then right next to my first arrow, there is an option to run polls. And at any stage I can add, if you look at where my cursor is moving, I can add more students to the class. So I may not have had a student, you know, in the month of February, but in March I had 2 students. So I can add them to the class. So I can keep adding students to the class from there. So it's like a grade book. It's like, yeah, a whole lot of things that you could do with the Navigator software. And I can have the assignment summary. Of course, I had to remove the data there for the students I had, but you could actually have all the assignment data for them. Okay. And I was talking initially about the handheld view on the software and the computer view. So probably what I may do is just escape and go to my calculator. And at the moment, you'll see I'm in the document view, and that's the computer view. So I'm going to escape from here. And now if I do that, so that's the handheld and that's the computer view. So you can see a difference. Handheld is probably better when you have got students in the class. And you can change the keypad option there. You can just have the handheld, then you won't see the side screen. You can have the full handheld, just not the keypad, and that's there. So I prefer this option. And every time you click a key, you'll see it goes red. So the students can actually know what you are doing. So every key that is clicked. So the last key I clicked was the delete key. So you can see it's red over there. So just want to demonstrate the notes page since I'm there. As I said, if I do Control M, it's a matchbox, and I can actually do a calculation on the notes page. And if I hadn't done Control M, then I could actually add any text over there. I could add any image. So I could just do anything on the notes page. I think I'm probably running out of time, so I'll get back here and from the current slide. Okay, saving files. This is something very important. You generally would save a file as .tns, but I think this is something important that I need to mention. So if I go back to my calculator here, you will see there is an option, save as. And under save as, you will see there is file type TNS, which is the default, but TNSP is publish view. And publish view is something, once you start using it, you'll just want to keep using it again and again. So I'll just create a document in publish view, so you exactly know what it does. So that's the publish view. And now you can see I can actually add any application there. And that's place I can change the dimensions of my calculator page. I can do anything there. By the side of it, I can go and add a graphs page. I can actually go and create questions there. So I'm going to click cancel there. I can use a notes page, data, statistics, so any of those applications. But more importantly, what this also allows, I can go and drop an image there. So I've just added an image there. I can go and add media files. I can add a video. So the question is, you know, what's the benefit of all this? I can actually create a file with everything and put it on my learning management system. And the students basically have information to everything. I can add text over there. And I can add actually URLs to a site, whatever. So text, address. So basically anything that you want to do, you can do that. It's like creating a document in Word, but with all these features into it, and then you can upload it into your learning management system. And the good thing is you have created this once, you can use it year after year. And if there's anything that needs to change, you can just change it and it gets updated. So Publish View is one of the outstanding features of the TI teachers software. And I highly recommend that you use that. So you can resize the application, move the application anywhere on the page. You can insert media and save it on the learning management software or anywhere else. Okay, so let's see if I'm getting to the end. So that's something I've just shown you on the publish view. And okay, the STEM tasks. I've done these projects using the hub and everything else. So how is information carried over the internet? So we actually kind of made modems, and we use the binary system simulating planetary motion. Now I obviously don't have the time. So these are 10 projects on this page. We created dispensing machines, automated irrigation, and these actually are working models, everything done with the TI Inspire calculator, simulating mirrors. So if I look at the next one, planetary motion, friction and inclined planes, modeling, titration, sound analysis, color mixing. We created recently a 88 piano keyboard, and it plays really well. And basically all mathematical function modeling, Archimedes principle of flotation, data logging activities, roller coaster, skateboard park, Ferris wheel. So basically you can just do anything. And one other thing I need to mention, TI Inspire is a very good simulation software. So I have simulated all these things like the skating park, the Ferris wheel. So actually it shows the Ferris wheel moving and plotting a sine curve. So if you want to access all these resources, I will try and make them available to you. And I'm actually going to stop there because it's far too much information that you would have grabbed. Oh, one bit. You can do data logging by using the Vernier data quest, and that's basically a place where you could you could connect any of the sensors. You could yeah, there are several sensors that are available for the TI with Vernier Pro, and they work really well. So there can be assessments, STEM tasks, or anything. All right, I'm going to end there. And this is the link where you can actually go for programming and activities with Python and a whole lot of other things. So thank you for being patient listeners, and sorry if I was going too fast because we were time bound. I had to rush through it. So I am going to stop the share and hand you back to Hassan. Yeah.
Hi, I'm Revati here. Thank you so much, sir. Thank you, Mr. Sanjeev and Mrs. Shradha for for the informative session. And I also thank all the participants for joining with us today. We will be contacting you in person after the webinar to get your addresses. So we will send the goodie bags to all the participants. And we are also planning to send one calculator to the teachers who are interested to explore further. And if you are interested to recommend this calculator to your school, you can write to us. Our contact addresses are shown displayed in the screen. Email IDs and phone numbers. You can write to us. We will send you a calculator so you can explore further. And if you're interested, to recommend to the school. And we will be conducting series of webinars with different topics, and we are inviting speakers around the world. And we are also interested to visit the schools. If you're interested, you can let us know. We can visit your schools with our TQ trainers to conduct workshop for the teachers and students. And we are running an interesting introductory offer to the schools with a proper discount, and we also give free guidebooks for the schools. For the teachers, we are giving teacher software, and we will send you the information separately. If you write to us, we will share all the informations. Once again, thank you all for joining with us today. Happy evening to you all. Thank you.